Okay, so in this one, what we have is we have these two triangles. Let's say A, B, C, and another triangle, say D, E, F. Right? And in this one, what you do is you have that, okay, so what do we got? We got AB is the same thing as DE. We got BC is the same thing as EF. And we got AC is the same thing as DF, okay? Now, what we start with in this one is to say, we say that glue AC along DF. And since they're congruent, we can do this. Since AC is congruent to DF, we can do this. And what that's going to now look like is this quadrilateral. Right? This is now point A and D, B, A and D overlap, C and F overlap, E. And you can now draw BE. Okay, draw the segment joining B and E. And don't forget what we're given, right? Given this and this, right? Okay, well, now, once you draw BE, you should sort of look at triangle BCE or BFE, because this is now an overlapping point. So BCE, right, triangle BCE has BC congruent to CE. So, by isosceles triangle theorem, the corresponding angles must be congruent. So that means 1 is the same as 2, where I'm calling this 1 and that 2, obviously. So by isosceles triangle theorem, 1 is congruent to 2. And again, triangle BAE has BA congruent to EA, right? So again, by isosceles triangle theorem, we have that the corresponding angles are congruent, which in this case is 3 and 4. This was 2. I don't know why I got erased. Okay. So we got 3 is congruent to 4. And now we're going to say, by definition of congruent angles, measure of 1 equals measure of 2. And just in one, the same reason 3 is equal to 4. Okay. Now with this, I gotta put 2, right? Okay, now with this, we should see that B is equal to 1 plus 3, and E is equal to 2 plus 4. So we can say the measure of angle B is equal to the measure of angle 1 plus the measure of angle 3. And that the measure of angle E is equal to the measure of angle 2 plus the measure of angle 4. And these things both follow by angle addition. Angle addition axiom, right? If two angles form one angle, then their sum is equal to the measure of the third, right? These two angles obviously make up angle B, and then these two obviously make up angle E, so their sum must be the measure of B, and the sum of these two must be the measure of angle E. Now, we substitute into one of these two equations, and it won't matter which one, but you could say that the measure of angle B, instead of writing measure of angle 1, you know measure of angle 1 is the same thing as the measure of angle 2. And that the measure of angle 3 is the same thing as the measure of angle 4. So then I could write it like this, by substitution. And then, since now this is the same as this, it's clear that B and E are equal. The measure of B equals the measure of E by substitution. And then angle B is congruent to angle E by definition of congruent angles. And then you're done, because now you have, if you look at the original triangles, this is the same as this, which means by side, right? This side is the same as this side. This angle I just showed is the same as that angle. And then this side is the same as this side. So by side, angle, side, the two triangles are indeed congruent. By side, angle, side, triangle ABC is congruent to triangle DEF. And you're done.